So I'm Greg Ferguson. I'm the project manager for the Calandria Relief Ducts Cleaning, Inspection, Repair Tooling. And I'm here to talk to you today about the Calandria Relief Duct Inspection and Repair Project. Calandria Relief Ducts, their primary function is to vent the calandria in an overpressure condition. Secondary function of the Calandria Relief Ducts is to circulate helium gas and to remove the explosive hydrogen gas hazard. When they opened the ducts and did an inspection, they found that there was internal leaks, and this was allowing light water to leak into the pipes, down the pipes and into the calandria, which is negatively impacting the reactivity of the unit.
So in Unit 7, there are high levels of chloride within the ducts. Because of the chlorides, this is causing transgranular stress corrosion cracking. Light water is getting into the duct and it's degrading the moderator. So it is not a safety concern, it really is an economical concern. So our intent is to go in, remove those chlorides and inspect the state of those ducts in Unit 7.
So we're well engaged with the regulator, the CNSC, on this issue, developing the repair and inspection strategies. And that, because we're not dealing with a safety system or a safety issue here, that has given us some leeway in developing the repair and inspection approaches.
So we started the BASE project back in 2013. So the BASE tool set has been in operation since 2014. In this past fall in 2015, we started the weld inspection head and the cleaning head. There's
a cleaning system as noted, the delivery system, the crawler system, duct inspection system, balance line inspection system, FME barrier, and repair systems. All will be deployed in a joint team or vendor deployment strategy.
So the CRD toolset consists of a main inchworm crawling system. It has 3 interchangeable tool heads. So initially we go down, we clean the duct actually first with a separate tool set. Then we go down with the Morty system, which is a moderator relief duct inspection equipment. Morty is from here, which is where the cam lock is back. So the cam lock allows for the interchangeable tool heads, and there's 3 different interchangeable tool heads. So we go down, we deploy a bung at the bottom of the duct. This prevents and ensures no foreign material gets into the calandria. We change out the tool heads and we go down with an inspection system to do a volumetric ND inspection with eddy current and ultrasonics of the duct. And then lastly, we go down with a 2-inch balance line deployment tool and we push a snake to the 2-inch balance line, which is connects the 2 ducts together.
The deployment window is currently around 28 days. The UT scans are quite lengthy. The duration of a weld onlay is somewhere in the order of about 40 hours. We're working in parallel ducts, north and south ducts at the same time to try to keep that outage window under control, but it is quite a lengthy deployment.
So I think one of the keys to the success of this project is the Kinectrics and Bruce Power Human Performance Program. So we've worked very closely with Bruce Power to implement that HU program here and to make sure all the crews are using that during training, procedure preparation, everything to make sure we have a successful outage. Bruce Power and Kinectrics have worked very closely together for the last 3 years, and it's been a really important and great partnership between both companies.